Great. So yeah, I'm Yves. And today I wanted to talk about KISS. And if you were expecting these guys to show up, well, you're at the wrong conference, basically. Or you had the wrong expectations of this talk. But you have to grant it to AI. It generates lovely pictures. That's one thing it does. No, I wanted to talk about keeping it simple and straightforward. I work with a lot of people that try to do event sourcing or implement event sourcing, and there's this recurring theme in that they struggle in doing that. And I think what's simple is the questions they ask, and what's problematic probably is the answers they get. So the simplicity in today's talk, it's a very simple talk, it's a very basic talk. And I'm glad it's scheduled right now and not at the end of the conference, because that wouldn't make sense. Trying to keep things simple. So we're gonna explore that basically a little bit. So an interesting question is, how do we learn event sourcing? And I have to say, these days, you are privileged, basically, because when I started out, the only way to learn about event sourcing was booking a course with Greg Young, basically taking notes of everything he was saying and then trying to make sense of those notes a week later, basically. But today you have a Discord community, you have GitHub repositories for pretty much every programming language. I just mentioned a few, right? You have YouTube channels, you have even Oscar's blog is on here. So these people, they tend to share a lot of this information. And I think that's a good thing, because it lowers the barrier to getting the information that you need out of it. Now, there's another question, which is, how do we learn about event sourcing? And it's a little bit more grim, I would say. Over the course of time, I've seen two personas, basically. Not the same, not groups of people, but I mean, you can be the same persona or another persona, basically, depending on the context and the technology. But for event sourcing, I kind of see two people. And on the one hand, you have the seekers. And these are the people that stumble upon event sourcing and they think, wow, what's that? Great. And they go out and they seek things and they read a blog post and they get more interested. They try an example, they fail, they come to the community, they ask questions, they fail again, they ask more questions. But gradually they're crunching all that knowledge, basically. And they're fairly optimistic about this whole thing because they're getting somewhere. They're getting some value out of this. And on the other end, these are what I would call the endurers. These are the people that get told to use event sourcing without really understanding what event sourcing is. Chances are they have to learn it on the job, right? They're not supported very well in doing so. If they're lucky, there's some training. If they're lucky, there's some consultant helping them out. And so they get frustrated fairly easy about event sourcing. And they try to go back to the things they know, like relational modeling and things like that. So I think it's important, if you want this to make a success, if you want to keep it simple, you have to bring in the proper support, right? And the next question they have, I mean, both of these groups, basically, that's one of the odd things that I find, is that they both have the same questions. Like, what is event sourcing? And it's a good way to start this conference, I think, by just defining what it is, right? So one floating definition of it is that it's the act of storing facts in an append-only log. That's it, that's the pattern. Does it tell you much? When you're a rookie, probably not. What's important is the persistence aspect. What's also important is the word facts or events, basically, using past tense and hammering that the whole time. So one quick visual representation might be, oh, we have a log and there's an event. And then after that event comes another event. So you're kind of planting seeds when you're showing people this. Seeds of, well, there's ordering to things, right? And things have happened. We're not talking about things that are going to happen. But it clicks to them basically when you start translating that to a domain they know. Like in this example here, I'm very fond of casino wallets. I don't do any gambling, but I like modeling it. And so I modeled a player's wallet. And what happened in the history basically is that I gave a wallet to a player, then the player deposited some money into the wallet. The player placed a bet, and unfortunately, he lost it. So you're kind of telling a story, a chronology of things. You're also making clear that we need to choose some kind of partitioning, because we're not doing this for the one player, we're doing this for all the players in the casino, right? So you're planting seeds at that point where, yeah, there's some segregation here going on. And so gradually people become aware of what a stream is. Stream is a boundary basically into which you put certain events. What stream boundary you choose? Well, that's up to you. Most stores actually support this type of concept. And people naively then think, well, yeah, you know, this isn't all that great. I mean, there's no concurrency here. But you'd be wrong, right? Because how does the player get its wallet? Probably he signs up in some automated system when he passed through KYC, says, okay, this player is vetted. Now we can actually give him a wallet and he can start come into our system and do something with it. How does money get into his wallet? Well, it's probably the banking system where some money is being deposited on the casino account, the banking account, and then in the casino system, in their player records, they know that this player is associated with that bank account. Ergo, it needs to go in this wallet of this player over here. Now, I'm not suggesting that the banking system goes off and writes into the player's wallet stream and that the gaming system, when you place a bet, also does that. I'm just saying that these other systems affect maybe the wallet subsystem or the player wallet subsystem. And so there is a level of concurrency that's going to happen at that point in time. So it's important to kind of gradually bring people up to speed into all these key concepts, but do it fairly gentle, keeping it simple, using examples. And then we zoom out some more and you realize that, you know what, it's not our wallet system that's just event sourced, it's also our gaming subsystem and managing games and our banking subsystem that tracks, I don't know, quarterly deposits. So you plant the seed of, yeah, there needs to be some notion of namespacing, because imagine if the developers of the wallet subsystem thought, well, we're not going to call this a wallet, we're going to call this an account. And the guys in the banking subsystem, they say, well, we're not going to call this, well, they're going to call it an account, obviously. So if both of them say naively, well, our streams are called account dash and some UUID or something like that, then obviously, well, the chances that UUIDs are going to clash is probably minimal. But you get the idea that it's muddying the waters of which data belongs to which subsystem. And then the next question obviously comes in, well, I heard about this CQRS thing, and what does it have to do with event sourcing? And the answer is absolutely nothing. But it happens so that these two go well together. I would say that CQRS is an enabler for event sourcing, right? So CQRS, very simple pattern. At the service level, we say on the one hand, we have commands, things that change our system, and on the other hand, we have queries, things that read from our system. They don't change our system, right? At the service level, we kind of make this split. There's nothing about CQRS that says that underneath it, there needs to be two models or even event source model or things like that. It's just that this splitting. But by doing this splitting, you're enabling event sourcing. Why? Because event sourcing and its projections and all that, yeah, that kind of fits, right? You know, your right model does all the behavior and the state changes, and then your projections are more to support what you're reading. There's not one read model, there's probably 100 read models. All your analytics, all your UIs and APIs, they're all sitting on top of their own proper read models, or maybe share one. All design choices. Ha, do we really have to go there? This is such a deceivingly simple question, but let's try something. I mean, it's the morning session, so we could use some exercise, right? So I'm going to show you a list of terms, reasons to use event sourcing. What I'd like you to do is, by show of hands, I'm going to call out 3 of them. And if you think, well, this is a reason I chose event sourcing, or I would choose event sourcing, just raise your hand and look around. So by show of hands, let's say, I'll give you a second to read it. Let's say, yeah, the first one, who would choose event sourcing for auditing capabilities? Yeah, a lot of people. Well, let's use another one. For occasionally connected systems. Oh. Let's say for easier bitemporal modeling. I've seen it, maybe you haven't seen it, but there's different hands going up. And this is why it's hard to explain to people what's a good use case for event sourcing, because people, especially rookies, they're seeking finite things. They're seeking sound and solid advice that's never going to change. And that's just not the case with event sourcing. With event sourcing, you can apply it in really different contexts. So to keep things simple, I think it's just a matter of knowing your context in which you operate pretty well and making deliberate choices about the value that you're going to get out of it. So my personal motivation over the years has been to have a record of authoritative domain-specific facts that I can reinterpret in a variety of ways, but most importantly, it's because reverse engineering the past is next to impossible. I worked for, I think, 4 years on projects and products basically that were doing just that. Let's look at this column over there. And if that row in there has this value over here, then this has happened. Our systems are leaking basically very basic information by modeling it in a different way. So to me, recording it just makes that magic 8-ball go away. When should we use event sourcing? Isn't that kind of the same as why we should use event sourcing? I would say it's a little spin on it. It's a little bit more nuanced. I think if your problem space is behavior-oriented and coupled to time, yeah, it's going to be probably a lot easier to apply event sourcing than when you have a data-oriented problem, right? But something odd happens with seekers. And I've been a seeker, and I've fallen into this trap. And surprise, surprise, yeah, let's event source all the things. And that gets you into trouble too. Because I've seen 2 things, right? People that within their company say, we're going to event source everything. What's going to happen is that you're going to get this cookie cutter architecture, and you're going to get these endurers that say, why am I doing this in this way? I don't understand it. I feel pain in doing it this way. And it could very well be because they don't understand it, but it could also be that, yeah, the problem they're working on is not a good fit for event sourcing. I would say, though, overall, if you're doing line of business application, then probably 90% of what you're doing is a good fit for applying it. But it's a common trap that people fall into, is trying to event source everything. And there's another time when not to do event sourcing. It's when your events start looking like this. right? You just created a fancy language around, yeah, how do I invent SQL in a different way, right? It happens for a variety of reasons, though. I mean, it's easy to point a finger and say, hey, yeah, you just built SQL, but it happens for a variety of ways in the sense that, how should I say this? Sometimes when you're working in a company and they're not convinced about event sourcing, and the developers try to do event sourcing and they're trying to do their best to come up with a model, but they're just not getting that feedback, this is often what you get. Another case is when, for example, when the developers are working in probably a more ERP system, right? Where they're selling to so many customers that each customer says, hey, I want this field and I want that field. And you get very fragmented events, basically, almost like, hey, this field changed. Oh, wow, great. I mean, you get property sourcing at that point. There's also another reason why this happens. I don't know about all you guys, but English is not my first language. And a lot of developers I meet have problems with English in the sense that the proficiency in English basically is most often a problem. Your depth of vocabulary is a problem, right? You'd think, well, that's a developer-only problem. Well, no, it's also a problem with people in product. It's also a problem with people in design and so on. So unless you have somebody that's speaking English natively or is very fluent in it, the quality of this will also be reflected in here. So how you name your events will be reflected in this. So all of these things could be a reason why we see this end result. Not as extreme, obviously, but that's what gets us there. So again, awareness of your context is going to enable you to keep it simple and appropriate, right? This is the next question that comes up. Should we express because yeah, they think, well, yeah, if we can't express it in English, should we express it in our native language? Entirely possible. I'm in the camp of there's a boatload of reasons not to do this. And the reasons often are, the reason to do it to me is that if you're in a domestic market, you're living in a country with maybe one predominant language, you are going to hire developers only in your own country or are willing to teach them the language. That's the case where I entertain. There's only a few industries basically also where this really makes sense, in the sense that legislation, for example, would be something that I do there, but where I would use native language. Why? Because some terms simply don't translate. But it also happens in poorly regulated industries or new industries, right? Now, if they're all across the globe, and it's usually not a problem to come up with English. Should we use a framework to apply event sourcing? Let me just put on my consultant hat here and give you the well-known answer of no. You were kind of expecting it depends, right? Event sourcing is so simple. It's reading from a stream and writing to a stream. It's basically all it is. If we're talking about storing, at least, about that fact. I know I'm simplifying, but you don't need a framework for that. But if we're using a framework, are we doing it wrong? No, of course not, right? If I'm a seeker, I would like a framework because I can learn from the framework. I can look into the framework. How are they doing that? I might even write my own. Not to open source it because we have enough of those, unless there's none in your ecosystem and you feel ambitious to kind of support it, go ahead. As an endurer, I would pray for such a framework. Why? Because the questions have been framed and worked, pun intended. right? So this is not to bash on frameworks. I think the gist of it is no, you don't need it, but if you're getting some value out of it, keep it simple, use it. Oh, what does event sourcing look like in practice though? And this is a question I often get. Now I'm not gonna stoop down to the code level because it's gonna be too detailed and it's gonna be different for any language. There's kind of these patterns that you're able to see. And so the general idea is when you're applying event sourcing, mostly in line of business though, is that there's some external trigger that gets caught by a handler whose responsibility is kind of more to coordinate stuff, basically. And what it does, it goes off and reads events from the event stream. It replays those events onto an entity, hands that entity back to the handler. The handler calls the entity and calls some method on it. When that's done, the handler or the client then asks the entity, hey, what did you record internally? This is a very object-oriented programming style. This is what has been promoted by Greg Young, I would say. There's a different style of doing this where the entity would, for example, say, oh, if you're calling a method on me that is going to change my state, I'm going to hand you back the events. Same deal. The cycle is not going to change, basically, because of that. And then at the end of it, obviously, the newly produced events get appended to the event stream. And so the cycle we get into is read the stream, hydrate, decide, and then the new events we append. And then we drop everything on the floor as if we have amnesia, basically, and we wait for the next trigger to come in, and we do this whole dance again. And this is probably the easiest model that you can start out with. Keep it simple, right? If you're starting out with this, then until you hit, I don't know, performance issues, right, then this makes sense to me. I just want to give a particular shout out to Jeremy Chassin. He's coming up with the decider pattern. And so if you're in a functional programming language, basically, then yeah, there's no entity object as such. There's the state of the entity because yeah, functional programming is functions plus data. So it's a little bit different in the sense that when events get read, you replay onto the state, whether or not you mutate the state or create new state as you replay. That's an implementation detail to me. And then you pass in basically the current state and the trigger to the side function, and that comes back with new events, and we append the new events. Kind of the same deal. If you keep your state in memory, you can do catch up. Like if you're not dropping your state on the floor the whole time, you can wait for the next trigger to come in, like actor framework, for example, would be a good example for doing this. They're able to hold the state in memory, and then when the next message comes in, they don't have to read all of the event store. I mean, even if your actor framework is able to guarantee you that there's only one single instance running, then you don't need to do any catch-up. If it doesn't give you that guarantee, you can do some catch-up, basically, meaning that you read what has changed since you last read or written. Great. So this is kind of practically what you go through with event sourcing on the right model side. I'm not going to talk about projections and all that. I mean, that would take me a little bit too far. So what's this replay thing you keep mentioning, right? This is something that people struggle with, I think, initially. It's very simple. You have to imagine that there's some cursor, and you're moving this cursor from left to right through your stream, basically. And as you reach each event, you're thinking about, so how does this affect the state I need over here? Well, what's the state I need over here? The state that you need over here is any data that you're going to be using to support future triggers. Right? Any future decision that you might want to take based on past decisions that you took, basically, is coming from here. So this is a roll-up of your past history in a shape that's going to make it easier, basically, to make new decisions. So very simple example, when I gave the wallet to the player, his balance is 0, obviously. When he deposits, We're at 50. When he takes 20 out, obviously we're at 30. And so that's the current state when we're here. So if he now places a bet and likes to take 30, well, he can't. Oh, he can, yeah. If he likes to take 40, yeah. Yeah, that's also the next question that comes, because they're starting to think about streams, and yeah, my stream can get very long, so isn't that going to be a problem? And I would say, if you want to keep it simple, don't go there. Observe, measure when and if this becomes a problem. If the action that you're doing is not on a user's hot path, what's a couple more cycles to spend? But at some point, yeah, it might become a necessity. And there's two kind of ways in which you can do this that I've seen most community members do this. And one is called snapshotting. And what it means, like in this case, I've said, well, every third event, basically, I'm going to take a snapshot of the state. I'm going to store it somewhere. And then when a next behavior comes in, I'm going to start off from the snapshot. I know what I took a snapshot of. So it must mean that I just need to read 4, basically, or anything that came after it, and apply it to this state that I have over here, and I'm ready to go. So think about it this way. If there was like, I don't know, 100,000 before here, and I took a snapshot, it's probably going to take less time for me to read the snapshot and just maybe a few events than the 100,000 that's over here. Like, I see a lot of applications, basically event sourced, and 50% of their time is spent in I/O and encoding. That's just the thing with event sourcing. This is a technical optimization technique, right? But people jump at it for some reason. I think it's more of a last resort type of thing. There's a more interesting pattern, and I call it breaking streams. We can do it either explicitly or by time. So I'll give you a quick example here. So I got my wallet again. And when my wallet starts to wear, basically I can go and buy a new wallet. So in the casino, basically, I can basically say, well, you know what? Let's exchange this player's wallet for another wallet. So the player wallet got exchanged is written into the old wallet, and the player got a new wallet is written into the new wallet. And the only thing that we need to remember in this simplified model, obviously, is the balance they have at that point in time. I took a bet once with somebody basically saying that I could break any stream there is. Often what we're trying to do is we're trying to find seams within the business context that allow us to do this. But there's nothing wrong if it doesn't align basically to go ahead and add them to your model. Your model is not static. It's influenced by what you do. It's influenced by what the business does. So it's symbiotic almost. And there's another interesting property about this. I exchanged the wallet, but what caused the wallet to be exchanged, right? What we've done here is we've decoupled basically the act of taking a decision and what caused us to take that decision. It could have been somewhere somebody sitting and pressing a button saying, exchange this wall for a new one. It could have been an analytics system that has been running for years that has been observing this particular player, and it knows that this player doesn't play on Monday, so Monday is probably a good day to exchange his wallet. So you can make this as easy as you want or as complex as you want. From the perspective of this model, it doesn't change a damn thing. So as I said, there's also a variant of this where you can do this using time, right? So here, a game went into halftime, and when it resumes, there's a game resumed event. And now I split up 2 streams. There's no correlation between these 2 things. We can have correlation. We can have this thing pointing to here and vice versa. That's all possible. So playing around with your domain basically is going to allow you to break streams and not get into this conundrum of, yeah, my streams are getting very long. I don't know which one we should use. There's textual and there's binary, and so encoding, serialization, same thing. Which one we should use? Well, it's going to depend more from an operational perspective, I think. Is that if you're dealing with binary, do you want some interoperability out of it? Like, do you work in a heterogeneous environment where the write model might be written in F# and the projection model might be written in Go? Well, maybe protobuf is a good intermediate there. Are you doing a lot with web APIs or APIs in general over HTTP? Well, maybe JSON is more appropriate for you. I would say overall textual is easier to diagnose. You're able to look at it, you see what's in the events. With binary, it's always a matter of where's the schema, how do I get the schema in there, how do I get to view that damn thing? So there's a lot of friction around it. So again here, keeping it simple for your team, if you're starting out, don't go binary, I think, go textual until you can. Now maybe the framework has already made that decision for you, easy then, right? Oh yeah, this is a fun one. Can we put value objects on our events? So somebody has read about domain-driven design and they think, well, can we do this? And my answer is it doesn't matter because you're not getting it, in the sense that your event that you have here on your sticky note that's on your whiteboard, your event that you got here in its primitive form that you've got in your programming language, and your event that you got here in your programming language using these value objects, they're the same event. Nothing is different about them. They are different representations of them. That means that it's kind of the same question of, do my events and my commands belong to my domain model? Well, if you constructed them using value objects, they kind of do. How do I get to serialize my value objects? Well, you don't, I mean, you could do that, but you could also map between the primitive form or the message model that you're using on the outside, maybe HTTP, maybe RPC, onto your domain model. So if you heard about parse, don't validate, then that's kind of where this fits in. So it really doesn't matter, but, and yes, you can put value objects on your events. But you then have to kind of know what you're getting into, right? You're making some things harder and you're making different trade-offs. Keeping it simple, I'd start here, basically with primitives, to be honest, and then see how far that gets you. What's the best thing about event sourcing? Okay. What's the best thing about event sourcing? Well, here's my top 3. It's phenomenal what you get out of testing. It's not to be underestimated. In the sense that, yeah, if I want to develop a model basically using just my events and my commands, and when I write my tests, they're just at that right level. What do I mean by that? Ever been in those situations where you write tests and somebody else has written tests and code starts to break left, right, and center? When you're doing that with messages, there's a lot less of that. Why? Because what's the message going in? Well, let's see. So if I'm testing entities or processes, I have a bunch of givens, which is events, basically. So given these events have happened, when this command happened, then I expect these events to come out. What's more easier than that? Testing your whole system. Not your whole system in the sense of, yeah, everything integrated. You can choose how far away from the system under test you're going. Like, I can run the same tests, these type of tests basically in memory. I can run them with an event store integrated, I can even run them with an HTTP pipeline integrated. I can spin up a cluster and do the whole thing basically. Is it going to teach me a lot? Is it going to be a lot of value? Maybe in some cases. But if you're looking for fast feedback loops, then doing it in memory and using these GWT type of tests is great. And maybe you heard of Cucumber and think, well, I don't like writing text for them. But your messages, your events that you're already defined in your programming language are the things that you write. So you're not going to write a bunch of text for them. You're just going to write the messages and fill in the values for the messages, basically, and use that. And then if you want to get a description out of that, well, learn how to print your messages. Look at the message object and basically make a sentence off of it. So inverse it. And you can do the same for views and projections. So given these events have happened, then I should have this in my relational model or this document over here in my Elasticsearch cluster. You're also able to do that with to-do lists, meaning that you have a bunch of things that you need to do. And then when, for example, there's a bunch of notifications that you need to send, when send notification comes in, then there's a lot of notification sent events or commands depending on what you're doing. But if you're interested in these sort of things, I think the event modeling website has a lot of these patterns defined on it. There's also this Skillcast by Greg Young. You need to register, but it's worth a watch if you're into that. How do we integrate with other systems? Kind of, where does this come from, right? I get it. People are kind of used to having some trigger coming to some host, some write model, and then they call a third party to do something, and they want to write something to the event store. How do we do this? It's fine to do this way. And what I usually tell them to do is to look at the transactions, right? So if this third party, so the overall transaction, if there is one, I mean, if it comes in via HTTP and the thing on the other side is not going to retry, then, and it's not going to be durable, yeah, I don't know whether there's a transaction there or not. But if this is a queuing system and it comes in via a queue, basically, then if you fail somewhere, it goes back into the queue or that letter queue and comes back up, basically, and you can retry it. But still, what you have when you call a third party, you have another transaction with the third party, and you have your transaction with your event store. There's a couple of cases in which this works just as advertised. If this is a query and you're willing to accept different results when you retry, it's fine. If this is a command and the message coming in has some kind of message ID that you're able to relay so that, and this guy over here respects idempotency, you can do it again. But beware that there's obviously maybe some dangling thing over here if this transaction fails. All of these things you have to be willing to accept. I think in general, what we tend to favor in event sourcing is a little bit more asynchrony, a little bit more decoupling, a little bit more eventual consistency. So we're trying to keep our transactions small. Being able to reason about your system without, oh, I have to look here and I have to look in that log and what happened and how do I mean, even operationally, how do you recover from a situation like this? It's a bit of a mess, right? Not mentioning the cases before. So what we tend to favor is to just take the decision and react to the decision. Now, sometimes this is possible, sometimes this is not possible. But if your reaction is, hey, when a player got a wallet, basically send him a invitation mail or a, hey, welcome, you have 0 in your balance. Maybe deposit some, right? Maybe a little nudge. That's when you could have a reaction that sends it to, I don't know, SendGrid or whatever you have here as a third party. But the decision to send, well, not the decision to send the email, but the decision that you gave the wallet to the player, at least is then not jeopardized by the fact that, oh, SendGrid was down. we're not able to give the wallet to the player, right? You kind of take that to the side. It's not critical to your business process. There's variations on it where people like to project basically the work that needs to be done onto a to-do list and then have one or more workers sitting on top of that calling the third party. And this to-do list could be just a relational table basically with all the stuff that needs to happen, and then each worker starts competing and picking basically work to do. So scales out, that's basically what you get, but you don't have to do this. You can use a queue instead, right? Depends on what you like and what you want to do. So queuing systems are obviously particularly good at this sort of thing. Great. What did I have here? Yeah. Obviously, sometimes people are going to say, yeah, that works great when the reaction comes afterwards, but what if I need some data before I actually do my command, or I kind of need to do something on my end, then do something on the with the third party, and then do something again on my end. Basically, that's where we get into workflows, Sagass, process managers. Only thing I can say is I'm working on something that's going to make this super simple to make. So make sure to follow my blog, basically, because I got something coming up in the next few weeks that is going to make that super easy to do and reason about. So the general idea is here then you have a transaction where you do something in write model, the workflow picks up on that and does the interaction with the third party, gets the reaction of that third party back, basically relays that to the workflow, and then we write again to our write model saying maybe, oh, it's confirmed, or here's the value that we've gotten. This diagram is a bit of a lie because where's the transactions around the workflow? There's transactions there obviously also, but I didn't want to pollute the diagram too much. So yeah, oh boy. I think that's almost the last question, yeah. How do we deal with files? This comes up every so often. And it's safe to say that most event source practitioners have taken a lesson from messaging, basically. The pattern that's known there is called claim checking. And so when you go to the airport, you check in your luggage, you get a receipt back, basically, and you travel with your receipt. We kind of do the same thing with the events, right? You get this game catalog over here. It's a big, giant PDF file. So instead of, well, we could put it in the event, right? But then you run into trouble with certain event stores because they have a limit on the amount of data that you're able to put in there. And also think about your consumers. Everybody has to get these, I don't know, maybe 3 megabyte events, basically, in which there's a file, and they're not interested in that file, they're interested in the event. Subtle trade-offs that you have to make there. So keeping it simple, basically, is to externalize it and provide a link to some kind of blob storage. I like to make this logical because facts remain there for a very long time. Like your events are probably going to outlive your application. If you put in, yeah, it's in this bucket over there in AWS, maybe not the best of ideas, unless you have some way sitting in between that remembers historically what we used AWS for and what we moved it to. So maybe it's better to give some kind of identifier to your blob and have something else basically do the figuring out of where's that blob sitting right now. But that's the general gist of it, right? And then so if somebody gets the event and wants the file, it just follows the link. That's the agreement that you make. There's a variation on this where you could do this conditionally. Like, so if the file is less than 1 megabyte, basically I'm going to put it in the event. If it's larger, then I'm going to store it anyway somewhere else. You could do this on size. You could do this based on the sensitivity of the document. or the status of the customer, or I don't know what reasons you have. So again, decoupling the reason why you would do it conditionally from the actual act of doing it. So what you would have at that point on your event would be two fields saying, here's the content type and here's the content data. Content type is going to tell you it's application/octet stream. Okay, so there's the binary in here. The other one is going to be, I don't know what the MIME type is for a link, but something along those lines, basically. So that's a useful trick, basically, to do it conditionally. Another variation on this is to, this is a command, blue, this is an event, yellow. So I'm kind of trying to, well, orange, obviously. I'm trying to respect the color coding of event storming here. So when a command comes in, it has a link to the game catalog that was uploaded. And that puts an interesting twist on things, because how did it come into this blob storage? Well, these days you have a lot of options, right? You can get signed URLs if you're in the cloud, where people are then able to upload in the UI, or you have some UI toolkit that does the uploading for you. You get back an identity or a URL, basically, and you can put in the URL. So that's kind of the idea. But you kind of separate the space in which people upload, and then the space in which you want to remember the content that they uploaded. And the reason to do this is because if you expect that a lot of transactions on this end might fail or not pass certain criteria, then you might be stuck with a lot of blobs in your uploading, basically, where only a small fraction of those you want to keep. So the event acts as a trigger, basically, to say, to a reaction that says, you know what, I'm going to copy this content over here I got from the event, and I'm going to put it in permanent space. And you take this long enough so that if for some reason you have some downtime here, you don't run into trouble. Okay. 3 minutes? Yeah, okay. I should be able to do that. How do you deal with uniqueness? This is the most often asked question. 3 ways to do that. Make your stream names the thing that needs to be unique. Most event stores, if you're trying to take a stream name and it's already taken, boom, you're not able to write to it or claim it. Obviously, you get into trouble. I changed my email address, so oops, what now? Do I get a new stream? What with my history? So, bit finicky, this type of solution. So the other one is that you create this Uber stream, or that basically takes care of that. Either it takes care of all the behavior, or it takes care of this uniqueness behavior. So when a player joins, basically, you keep track of that. And so you're able to build an in-memory index of that. And then when you try to claim a new name, you're able to tell relatively easy whether or not it's taken. It scales pretty far. People think, well, yeah, but what if I have 1 million users? Well, yeah, that's not a lot of data in memory. So people start panicking really fast about this, but obviously, you know your context best, so not going to make any wild arguments about this. And then the other thing is that you reserve your usernames in this case. So the things you want unique, you have some other dedicated store that does that for you, so that you kind of take it out of your stream design. And then changing your email address basically becomes a little bit easier, because you don't have to swap out a new stream at that point. You're able to claim the new name, do the business process over here. If that fails for some reason, this should have an auto-release mechanism, obviously. Once that's completed, this should have a confirmation mechanism, meaning that, yeah, I've actually taken this name. So it's like a concert ticket. You have some kind of window, basically, in which it's kind of in limbo. There's a hold on it, but you need to confirm it. Dear Lord, I managed to end on time.